We are now solving problem 24 from the AMC 10B from 2019. Define a sequence recursively by x naught is 5 and x of n plus 1 equals x squared of n plus 5xn plus 4 over xn plus 6 for all non-negative integers n. Let m be the least positive integer such that x of m is less than or equal to 4 plus 1 over 2 to the power of 20. In which intervals does m lie? So, I don't really want like the x's. So let's just subtract the 4. So we get xm minus 4 is less than or equal to 1 over 2 to the power of 20. Now, what we want to do, why we subtracted this 4 is the reason why we're doing this. We want to substitute this for y of m. Or just like y in general, 2 to the power of 20. So, once we substitute this substitution that we made into here and simplifying, we get that y of n plus 1 plus 4. We add 4 here because this is xm minus 4 is equal to y of n plus 5 times y of n minus 8 over y of n plus 10, since there's 4 more now. So, what we get when we subtract 4 from both sides is we get that y of n plus 1 is equal to, still going to be y of n plus 10, but now this is going to be y of n squared plus 9yn when you simplify it. Now, the denominator we see we can take something out. We can take the factor of y of n because when you multiply by fractions, when you multiply a number by a fraction, like a fraction by a number, only the top number is changed unless if you're simplifying it. So we get that this is y of n times y of n plus 9 over y of n plus 10. Now we clearly see as y of n value gets smaller, this gets closer and closer to approaching the fraction 9 over 10. So we have that. So this is close to approaching 9 over 10. And there's like, and now we know that x naught is 5. We can solve for y naught. Since y naught is x naught minus 4, that is 5 minus 4, or 1. So now, y of 0 plus 1 is that's just 1. This is now y naught times y naught plus 9 over y naught plus 10. And in this case, this is just 1. So this is 1 times 10 over 11. So this is 10 over 11. We have these two fractions where this is bounded by it. Since this will be always like by a bit greater than 9/10, we can say that whatever like it is, it's going to be bounded by these two fractions. We also know that we see a sequence coming on. Let's just do y2. y2 is going to be y1, which is all this, times, so we defined a sequence like this. This is y1 plus 9 over y1 plus 10. And why I'm not writing, this is 10. And why I'm not writing y1 in here is because we know that y1 is this. So whatever yk is, we can define a sequence recursively for k factors, where k like terms, where it starts at y0 times y naught plus 9 over y naught plus 10 times ... until you multiply it until yk plus 9 over yk plus 10. This is how the sequence goes. as you notice, you can just keep on multiplying it. If k is infinity, then this sequence will keep on going until infinity. So we have this piece of information. We have k, this is the number of terms, so therefore this is going to be in between 9/10 to the power of k is this is y of k, and it's going to be like this to the power of k. It's bounded by these regions, but y of k can be 10 over 11 to the power of k because we solved this to be 10 over 11 of k, whereas over here we estimated the fraction to be over here. Since y of n gets infinitesimally close to 0, it has to be a bit greater. So now what we notice is that let's just start testing powers for 9 out of 10. Once we test it a few times, we see that this 9/10 to the power of 6 is approximately 1/2. So to get to 1/2 to the power of 20, we want 9/10 to the power of 6 to the power of 20. This is also approximately 1/2 to the power of 20. So what we get is about 6 times 20, or 120. And it says in the following intervals lie. 120 clearly lies in the interval 81 and 242. So C is our answer, even though this is just an estimate.